All right, so solving quadratic inequalities. So what we're looking for here is all the values that will be greater than 0, which means we're looking for positive. That's what it's asking for. If it says we're looking for things that are less than 0, we're looking for negatives, right? So we're looking for x values that we can plug in that will be positive. Well, in order to go positive, you have to go through 0. So if you're negative down here and positive up here, you've got to go through 0. So that's where we start. We first find out when do these equal 0. So when x is 7 and x is negative 3, that's when we're at 0. And so we want to put them on the graph. And we're going to put them on the graph using open dots because this is not equal. Since it's not equal, we use open dots. And so now that we know it has to go from negative to 0 to positive, then all we have to do now is find out which of these regions are going to be negative. That's their only choices. We've already found out when it's 0, so this region can only be negative or positive. And we're looking for positive. So to do that, you just pick a number, any number you want. So I'm going to pick negative 4, I'm going to pick 0, and I'm going to pick 10. We can pick any value you want in here. We can pick a 1 or a 2. Same thing over here, we could pick negative 100. And all we do is plug it in to our inequality. And that would give us negative 11, negative 1, which is 11. And 11 is positive, so we shade. So again, if we are looking for greater than 0, we are looking for positive. All right, let's try the middle. So we have 0 minus 7, 0 plus 3. Greater than 0. Oh, there we go. Negative 7, 3. That's negative 21. And that is not greater than 0. So we put a big X in that region. So that region's out. It's not part of our answer. Then we move on to the last one. And a positive times a positive is a positive, which is greater than 0. So we shade. And that's everything. Now we can write our answer. So we're going from negative infinity, always parenthesis, to negative 3, and since it doesn't equal it, parenthesis. And then we're also going from 7 to infinity. All you have to do is write the answers in interval notation. Put a union in between it, and that's everything. That's our answer. So the whole of steps is number 1, find out when does it equal 0. Number 2, graph it and test some points. And whichever regions come out true, that's part of your answer. All right, let's look at another one. Okay, so since this one's not factored yet, we have to find out when it equals 0. In order to do that, we have to factor it. So that would be s minus 6 and s plus 2. So s minus 6 equals 0. S plus 2 equals 0, so s is negative 2 and 6. Now since it equals it, we get to use a closed dot. So we put a closed dot on there for negative 2 and a closed dot for 6. And now it's either going to be positive, 0, or negative. That's it. Okay? So let's pick some numbers to test. How about negative 5, 0 again, and pick 10 again. So we plug in negative 5. You can use the original or you can use the factored form. I like using the factored form. And that has to be less than 0. Now if it's less than 0, we're looking for negatives. That's what we're looking for. So that would be negative 11. That's negative 3. Negative times a negative is positive. All right, so that is not the region we want. Let's move on to the next one. 0. So 0 minus 6. 0 plus 2. less than or equal to 0. It's negative 6, 2, negative 12, and that is less than 0. So we're good. We shade. Last one. So that's 4, 12, 48. And that is not good. We needed negative. So cross it off. So there's it. We've got all of our regions. We've got our answer, which is bracket negative 2, 6, bracket, because it's equal. And that's it. So again, you factor to find out when it equals 0. And if it's not 0, that means it's positive or negative. And if it's positive or negative, whichever one answers our inequality, then that's the region we shade. All right, here's 2 for you to try. I'll get you started on the first one. You're trying to find out this situation. It has to be greater than or equal to 0. We need 0 to compare it. So this is 0, and then everything up here is positive, everything up here is negative. Okay? So factor it, place them on the graph, and then find the correct regions and write your answer. Alright, so after factoring it, you should have gotten these 2 points when it equals 0. And now you just have to look for the positives. This is the region we're looking for. When are they positive? So these came out true, which is giving you this. Alright, so on the last one I want to explain what's going on. So let's find out when does it equal 0. So we can actually use the square root property here. So we get plus or minus square root of 5 over 3. Let's find out what that is. So 5 square root divided by 3, 0.74. So let's put them on the graph. So that would be open dot negative square root of 5 over 3, and I'm going to put negative 0.74 as a reminder. And then over here, open dot square root of 5 over 3, and then 0.74 as a reminder. And this is when we have it less than 0. So again, we test them, and we get these. So I pick 2, negative 2, and 0. And then after testing them, I get that this is not less than 0. This one is less than 0, and this one is not less than 0. So shading-wise, we would take and cross this out, and shade the middle. But what's actually happening? Well, if you remember the parabola, this right here, it looks like this as a graph. And what we're looking for is when is our graph basically negative. So if you look at the graph, that's 0 right there. That's when we equaled 0. And so anything above would be positive, and anything below would be negative. So that makes these regions right here positive, and this region right here negative. This below right here is negative, which is why we're shading in between. If it had been positive, these two, then we would have shaded here and here. And that's it. So if you go back and look at them, the first one we wanted was positive, and we shaded the outside. You see them? Because there would be the parabola, and there's the positives. These come out to be negative. That's what we wanted. So if you draw the parabola, the bottom would have been the negative. And then the same thing here, parabola. We wanted greater than 0, which is the positives, the outsides, and so on. Now you do have to kind of think about it if you are going to use the parabola way. Now if this first number is negative, that means we have an inverted parabola, right? It's upside down. It's going downward. So everything would be flip-flopped. But doing the testing, all we're doing is trying to find out when do we have positive or negative. And on each one we're getting outside or inside. And that's it. So the 3 steps will always work. Solve to find out when it equals 0. Plug in some numbers in each region to find out When is it positive or negative? And if you're looking for the negatives, you shade the negative region. If you're looking for the positives, you shade the positive region. And that's it.